Hello, everybody. This is Mr. Walker. Our topic today is division. We want to focus on two types of problems that sometimes present an extra challenge or just kind of a little bit on the tricky side. I just want you to be aware of those today. By the end of this video, you will be able to recognize and solve two different types of tricky division problems. So let's take a look at what I'm just referring to as the first type. 243 divided by 8. Remember, we work from left to right, like always, and go digit by digit. 8 does not go into 2 at all, but it can go into 24. I'm just going to mark that off here. Like always, I'm just going to show my steps that I can solve a division problem using multiplication. I'm going to solve for n. And 8 times 3 does equal 24. I circle both. I'm going to use both numbers, the 3 and 24. We see that we have an exact match here. And when I just go to prove that and subtract, I have 0, 0. So no problem so far. Then we bring down the 3. And this is where sometimes it gets a little bit tricky. Some students will see this 3 by itself and see that 8 cannot fit into 3, and they conclude that this would be the remainder with an answer of 3 with a remainder of 3. And perhaps I'll write that over here. However, this would not be the correct answer. And let me show you why. In fact, I'm even going to kind of cross that out there. When we bring a number down, we still need to do the division step. So I'm going to do the same step as we always do. It's going to be 8 times n, in this case, equals 3. Well, when we go to our multiplication chart and look under 8, you'll notice that you won't see 3. In fact, the first one that you see is 8 and 3 is less. This particular chart does not show zeros, but n in this case would be equal to 0. So 8 times 0 would equal 0. It does not equal 3. I'm going to try to draw an oval around it this time to show that we're going to use both numbers. The 0 here goes right there. And this 0, like always, goes on the bottom. Notice that we do not have the same number, and when we subtract to find the difference, this 3 now does become our remainder. So our answer is 30 with a remainder of 3. So these kind of problems, when you have a smaller number that you bring down, can be a little bit tricky, and sometimes students will often put the wrong answer. In this case, 3 with a remainder of 3 would not be correct. The answer would be 30. So we're going to talk about that in another kind of problem today. The problem we just talked about really has a lot to do with place value, dividends, and quotients. And let me show you what I mean. I just rewrote the problem, 243 divided by 8, and I showed my steps down here with the gray marker. Place value is important for your dividend, which is 243, but also for your quotient. So for example, 243, the 2 is in the hundreds, the 4 is in the tens, and the 3 is in the ones. I extend that place value column down, you'll notice that when we did our first step, which was here, 8 times n equals 24, and we said, well, that was 3. Notice where we put the 3. The 3 is in the tens column. Now keep that in mind because I like to think of it this way. What makes sense? If you have 3 tens, and you're confused and you're a little bit tricky and you think, well, I think that's going to be 3 with a remainder of 3, that would be 3 ones. Remember that 3 tens would have to have 2 digits. So when you are in the habit of writing your quotient in the correct place value, that is a clue that there was another digit there. And that would be another way to help you solve that problem. So again, keep your place value in mind. If you develop good habits, that will help you on this kind of a tricky problem. Here's a second kind of tricky problem. 752 divided by 4. Remember that we work from left to right with our dividend and we go digit by digit. In this case, believe it or not, 4 does go into 7. Where many times we're used to going to that second digit, and some students begin to automatically just go to 2 digits. In this case, 4 does go into 7. So I'm going to write my equation. 4 times n equals 7. And I'm going to solve for n. Well, that would be 1, but it does not. 4 times 1 does not equal 7. It equals 4. We circle both numbers and use them just like always. But notice this time the 1 is going to come over the 7. Remember, that would be 7 hundreds. This would be tens. That would be ones. And we're analyzing digit by digit, in this case, the 700. So this 1 comes right there. What this implies is that your quotient or your answer is going to be 3 digits because a 1 is in the hundreds. And remember, that would be a 3-digit. The 4 comes here, and we work through our steps like always. 7 and 4 are not the same. Then we subtract. Now we're going to bring down only the 5. What we have here is 35 divided by 4, and we're going to write another equation. 4 times n equals our 35, and we're going to solve for n. Well, that would be 8. 4 times 8 does not equal 35, but it gets us close. It gets us to 32. I'm going to circle both numbers and use both numbers. This 8 goes over here. Notice that it's above the 5 in the tens, and the 32, like always, comes down here. When we evaluate that, they are not the same, they are different. We subtract and get a 3. Notice, though, that we still have another number to bring down. What we have here is 32 divided by 4. Now, you really can see that up here, but I'm just going to write it just to be thorough. 4 times n is equal to 32, and I'm going to solve for n. Well, I saw up here that it was 8. I circle both, the 8 I use up here, and the 32 is the same, so I have no remainders. So my answer would be 188. So again, a little bit tricky because sometimes the mistake that students will make is that they get conditioned to going over 2 digits when sometimes you can. Some tips: work left to right, digit by digit, and think of the umbrella, meaning that an umbrella, sometimes you use it when it rains, and sometimes you don't. Sometimes we need to go with a single digit. Remember, we go digit by digit, but sometimes we'll go with the first two. It just depends if you need to or not. Let's solve 362 divided by 9. And again, here are our steps to divide, multiply, subtract, and bring down. Go digit by digit. 9 does not go into 3, but it does go into 36. 9 times n equals 36. And to solve for n, that would be 4. And 9 times 4 does equal 36 exactly. I'm going to use both numbers. Notice that I'm putting the 4 above the correct place value, which would really be the tens in this case, the 36. I have an exact match. When I subtract, I get 0. Now I bring down the 2. Is this a remainder? No, it is not a remainder. So I'm going to have to work through. And the reason why, as you can see here, remember that this 4 is in the tens, this 2 is in the ones, this 3 is in the hundreds, which means if that's 4 tens, our quotient must be a 2-digit quotient, okay? So we're going to go 9 times n equals what? Equals 2. We're going to solve for n. Well, 9 times anything does not equal 2. Even 9 times 1 is too much. So this is going to be 9 times 0. 9 times 0, guess what? That does not equal 2. 9 times 0 equals 0. And I'm going to draw my ovals. I'm going to use both. This 0 on the top and this 0 down here. I can see they're not the same. And when I subtract, notice now that I have no more numbers to bring down. So now this is a remainder. So our answer is 40 with the remainder of 2. And finally, our second kind of tricky problem today, solve 529 divided by 3. Remember, we divide, multiply, subtract, and bring down. Go digit by digit. 3 does go into 5. I'm going to speed things up just a bit. 3 times 1 would equal 3. Maybe I will slow down just a tad. Our step here was 3 times n equals the 5, right? And when I solve for n, the best I can do is 1 times 3 is 3, not 5. That's where we got the 1 and the 3. Then I subtract. I get the 2. I bring down the 2, and now we're going to write an equation. 3 times n equals 22. The best I can do when I solve for n is 3 times 7, but it does not equal 22. It equals 21. I'm going to use both numbers. And the 21. Subtract. 2 take away 1 is 1. I still have one more number. Now we have 19 divided by 3. I'm going to use multiplication. 3 times n equals 19. And I'm going to solve for n. The best I can do for n would be 6. 3 times 6 does not equal 19, though. It actually equals 18. That's the closest I can get. I'm going to circle and use both numbers. 6 up top, 18 on the bottom. I can see that they're close, but they're not the same. To find out how close, I subtract, and my final answer is 176 with a remainder of 1. So keep in mind when you do the tricky problems, the importance of having good habits for your place value, writing your quotient above the appropriate place value and of the dividend, and also remember to go from left to right, digit by digit. Sometimes you can do one digit. It's not always two, and sometimes you don't. All right, thanks everybody. Hope this was helpful.